Hello and welcome to this video on galvanic cells. My name is Chem, and in this video we'll be working through the steps in drawing the notation for a galvanic cell with reactive electrodes. Previous lessons in this series focus on explaining the components in the setup of a typical galvanic cell with the beakers and wires and salt bridges. It's cumbersome to have to diagram what's going on in every cell, so in this lesson, we're going to review a shorthand form called the cell notation. This video will focus on the cell notation from when you have a reactive electrode, and you'll go through the minor modification required to write out the cell notation for an inert electrode in another video. I have on the bottom a sample cell notation for the redox reaction between X and Y. First, writing the cell notation requires that the information reads from left to right in the direction of electron flow. Solid Y will give up electrons to form the cation, and since Y is losing electrons and becoming oxidized, Y will be at the anode. The double vertical lines in the middle represent the salt bridge, and in a galvanic cell also serves as a reminder of the physical separation between two half cells, since it's often diagrammed with two separate beakers. The identity of the salt bridge isn't included in the cell notation because the ions themselves are inert and only function to reduce the buildup of electrostatic potential. On the right, the half cell denoted by X will gain the electrons being lost from the anode and become reduced, which means that the X half reaction will represent the cathode. Notice that the flow of electrons all point to the right. There is a single solid line separating the solid electrode and the ion in solution for that half reaction. The solids will also flank the ions on either end, not just because of notation, but because this also reflects the movement of electrons going from left to right. The stoichiometric coefficients for the balanced redox reaction do not factor into the cell notation. The ability of the molecules to gain or lose electrons are inherent to the molecule itself and do not depend on the identity of the other half reaction. Let's take a look at translating a reaction into cell notation. For the balanced redox reaction between Y and X, you can see that Y will donate electrons to form Y+. Using the mnemonic and ox redcat, oxidation occurs at the anode, so the Y electrode will be the anode. The X cation is gaining electrons that were given up by Y to form solid X, and since reduction happens at the cathode, X will be our cathode. Using the mnemonic fatcat, flow of electrons go from anode to cathode, so the anode is on the left and the cathode is on the right. The two phases are separated by a single solid line, and the double line separates the anode and the cathode. There are no stoichiometric coefficients in the cell notation. Let's go ahead and draw out the cell notation for the following redox reactions. In A, we have cadmium and copper reacting together. Solid cadmium is losing electrons to form cadmium ion, so this is the anode half reaction and will go on the left. The notation will go in the direction of electron flow. Cadmium solid first, then separated by a solid line to denote the phase, and then cadmium ion second. Next, draw the two double lines to denote the salt bridge. The second half of the reaction is copper ion gaining electrons to form solid copper, and following the direction of electron flow, copper ion will be written next, then copper solid at the end. Since copper is gaining electrons, this is the cathode. In B, aluminum and lead is reacting together. Aluminum is losing electrons to form aluminum ion, so solid aluminum will be written first, then aluminum ion. Solid double lines to separate out the two half reactions and denote the salt bridge. Loss of electrons means that aluminum is acting as the anode. Lead ion is gaining those electrons to form solid lead, so lead ion will be written next, separated by solid line, then solid lead. Since lead is gaining electrons, it is acting as the cathode. In this part of the applied question, we're asked to draw the balanced redox reaction based on the cell notation. This is a reaction between copper and silver. By notation and electron flow, electrons will be lost from the solid copper to form copper ion, and loss of electron means that this is at the anode. So in the reaction, Solid copper will be on the reactant side and copper ion is on the product side. On the other side of the double line, silver ions are gaining electrons to form solid silver, which means that silver is the cathode. So silver ions is on the reactant side and solid silver is on the product side. You might be tempted to call this done, but don't forget, this reaction also needs to be balanced. There's a total of 2 positive charges on the product side due to the copper ion, which must mean that there also must be a net +2 charge on the reactant side, which we can do by putting a 2 in front of the silver ion. The molecules themselves must also be balanced, so there must be a 2 in front of the solid silver in the product side as well. Cell notation is a common way to depict electrochemical cells, and the most important thing to remember is to follow the flow of electrons. Make sure you follow this video up with some practice.